In this video, we are going to explain about project titled Date Fruit Classification for Robotic Harvesting in a Natural Environment using Deep Learning. This project focuses on creating the highly effective mission vision framework specifically designed for date fruit harvesting robots. Date fruit cultivation plays a vital role in the agriculture industry of Middle East and North Africa countries, which are responsible for producing 91% of the world's dates. These dates are harvested and sold as fresh ripe fruits at three distinct stages of development. This characteristic makes them an ideal fruit for year-round export and consumption. Currently, manual harvesting is the prevalent method in date cultivation, where skilled laborers are required to climb palm trees in order to reach the date bunches. The main objective of this project is to put forward a highly effective machine learning framework tailored for date fruit harvesting robots. This framework encompasses two classification models which are employed to classify date fruit images in real time based on their type, maturity level, and determine the appropriate harvesting decision. These are the basic requirements that are needed to build this project. Hardware requirements: operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDEL with version 3.7. These are the modules that are implemented to develop this project. Upload date fruit dataset. To build the models for fruit classification, a date fruit dataset was obtained. These images serve as training data for the model. And the second module is fine-tune and transfer learning with VGG16. VGG16 is a pre-existing deep learning model was chosen as one of the pre-classifiers for date fruit classification. To adopt VGG16 to the specific task of date fruit classification, a process called fine-tuning and transfer learning was applied. In this process, the last prediction layer of VGG16 was modified and the dataset of date fruit images were added to this layer. By training the modified VGG16 model with the date fruit dataset, it became capable of classifying the date fruit based on type, maturity, and harvesting suitability. And the third module is fine-tune and transfer learning with AlexNet. This is similar to the VGG16. AlexNet, another established deep learning model, was used as a pre-classifier for date fruit classification. The process of fine-tuning and transfer learning was applied to adopt AlexNet for the specific task. The last prediction layer of AlexNet was adjusted and the date fruit dataset was incorporated into this layer. Training the modified AlexNet model with the date fruit dataset enabled it to classify the date fruits based on their type, maturity, and suitability for the harvesting. And the fourth module is date fruit classification with three classifiers. In this project, three classifiers were built for date fruit classification. These classifiers, constructed using the modified version of VGG16 and AlexNet, were designed to categorize the date fruits based on their type, maturity level, and harvesting suitability. And the final module is VGG16 and AlexNet accuracy graph. To evaluate the performance of modified VGG16 and AlexNet models in date fruit classification, accuracy graphs were generated. These graphs provide a visual representation of the accuracy achieved by the models during the training and testing phase. The accuracy graph offers insights into the effectiveness of the model and their ability to classify the date fruits accurately based on the chosen criteria. The execution of this project. Double-click on the run.bat file. In this screen, click on Upload Date Fruit Dataset and select the type folder and click on Select Folder. Here we can see the dataset is loaded. After that, clicking the Fine-Tune and Transfer Learning with VGG16. By this, the VGG16 model is generated. And if you want to see the CNN details, and we can see in the console, we can see the CNN layers of it. And click on fine tune and transfer learning with AlexNet button, and we can see that AlexNet model is generated. To see the CNN details, click on console and we can see these details. And click on date fruit classification with 3 classifiers and select the 4th one, and we can see the data type as colors, maturity is pre-tamer, and harvest is of colors tamer. In this way we can classify the date fruit. And finally click on VGG16 and AlexNet accuracy graph button. We get this graph as x-axis represents the algorithms we used in this project, and the y-axis represents the values assigned for each algorithm. And then close this graph. In this way, we can classify the date fruit for robust harvesting in a natural environment using deep learning. The conclusion of the project is that an efficient vision framework for date fruit harvesting robot in an orchard environment was proposed based on deep learning. The framework consisted of 3 models used to classify the date fruit bunches according to their type, maturity, and harvesting decision. Transfer learning with the fine-tune was used in the classification task. 2 pre-trained CNN models were investigated, namely the AlexNet and VGG16. To build a robust machine vision system, a rich image dataset of 5 data types for all maturity stages was used. The proposed date fruit classification model achieved the high accuracy and low classification time, making them suitable for real-time application in date fruit harvesting.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.